The biggest technology races in the world aren't always the ones you see on the surface. In fact, they're often the ones happening quietly in the background. While Tesla was showcasing its AI capabilities and software dominance, Toyota was doubling down on precision engineering, and BYD was expanding its battery empire. Meanwhile, without much publicity or noise, a Chinese company was quietly working on something few people noticed. Behind the scenes, a development was taking shape, one that could potentially reshape the entire future of the electric vehicle market. Today, when people talk about EV technology, Tesla is usually the first name that comes to mind. But the real story may be more complex than it appears. Because in the background, a Chinese automaker, Chery, has been developing something that isn't just another electric car. It could be a platform powerful enough to redefine how we think about vehicles altogether. So the question is Tesla truly the undisputed leader? Or is another company preparing to take an even bigger leap forward? If Chery's strategy succeeds, where will the next major shift in the EV world come from? What exactly is this company building, and how could it change the game? What you're about to see isn't just another product launch. It could represent a turning point. Before we dive deeper, make sure to subscribe so you don't miss future videos like this. While the world focused on the electric vehicle race, everything looked intense and dramatic from the outside. Headlines were everywhere. Trade wars escalated. Tariffs increased. Brands competed aggressively to dominate market share. America versus China. Europe versus Asia. Every company was fighting to expand its presence. There were constant launch events, press conferences, and announcements of new models. It felt like every day brought another breakthrough in the EV industry. But beneath all that noise and competition, something much more important was happening, a deeper technological transformation. While much of the industry was caught up in marketing battles and global rivalry, one company was quietly building a foundation that could shift the direction of the entire race. Instead of focusing on branding and hype, Chery's engineers were working behind the scenes, in labs, laying the groundwork for the future. They weren't just designing a new car. They were rethinking the way cars are built from the ground up. This is where the E0X platform comes in. It's not an adaptation of old petrol or diesel architecture. It's a structure designed from the beginning with electric vehicles in mind. Everything starts with an electric-first philosophy. The platform is paired with advanced Kunpeng's solid-state battery technology, which aims to overcome many of the limitations of traditional lithium-ion batteries. On top of that, it introduces a gigabit Ethernet-based electronic architecture, essentially turning the car into a high-speed, data-driven smart system rather than just a mechanical machine. But this raises an important question. If such a transformation is possible, why hasn't it already happened everywhere? The real challenge lies in legacy thinking. Many traditional automotive brands are still building electric vehicles using the same core philosophy developed for petrol and diesel cars. On the surface, these EVs may look modern and futuristic, but underneath, their foundation often comes from the old world. In many cases, manufacturers simply modify existing internal combustion engine platforms to make them electric. That means retaining structural elements that were originally designed around engines and transmissions. For example, some vehicles still carry a transmission tunnel, something an electric car doesn't actually need. There's often a heavy steel floor and a body structure made from numerous separately welded components. All of this comes from an era when the engine was the heart of the vehicle. It's like trying to play automotive Tetris, fitting something new into a space that was never designed for it. You adjust here, cut a little there, add reinforcement somewhere else, and eventually make it work. But that approach doesn't truly solve the problem. It just hides the limitations. There's a more effective approach known as clean sheet design. This means starting from scratch with a pure electric mindset without carrying over the structural compromises of combustion vehicles. That's where the real difference lies. One approach tries to modernize an old philosophy. The other completely reinvents it. And this is where the technological gap begins, the real revolution behind the E0X platform. If there's one element that truly changes the game in this new generation of vehicles, it's the way the car is built at its core. The shift isn't just about exterior styling or adding more features. It's about redefining the structure itself. Traditionally, many vehicles used 70 to 80 separate small steel components just to form the rear underbody. Each piece had to be manufactured individually and then welded together. On paper, that may sound straightforward, but every weld becomes a potential weak point. Over time, these joints can introduce vibration, unwanted noise, and even structural fatigue. The car might look solid from the outside, but internally, those numerous connection points can compromise long-term durability and performance. And that's exactly the kind of problem a clean-sheet next-generation platform aims to eliminate. The E0X platform completely rethinks traditional vehicle construction. Instead of assembling dozens of small metal pieces together, the entire rear underbody is manufactured as a single unit using a process called integrated die casting. In simple terms, what used to be built from many separate components is now created in one solid piece. This is made possible by using aerospace-grade aluminum alloy, the same type of high-quality material used in aircraft manufacturing. The aluminum is poured into specially designed molds and formed under thousands of tons of pressure. The result is a seamless, ultra-strong structure. The biggest advantage? The weak welding points that once limited structural strength are gone. When 70 to 80 welded components are replaced by one solid cast piece, the entire body becomes significantly more rigid and dependable. As a result, the E0X platform achieves a chassis torsional rigidity of around 40,000 Newton meters per degree. That may sound like just a technical figure, but in practical terms, it means the vehicle twists far less when cornering, hitting potholes, or driving under heavy load. Until recently, this level of stiffness was something you'd only expect from carbon fiber hypercars. Now it's being introduced into a mass-market platform, and you can feel the difference on the road. First, there's stability. A stronger chassis allows the suspension system to work more effectively. The car stays more balanced in sharp turns, and body roll is reduced. Second, there's safety. With fewer joints and a stronger unified structure, the vehicle is better prepared to handle impacts. In situations like side collisions, crash energy spreads more evenly throughout the frame instead of concentrating on a single weak weld point. Third, there's comfort and quietness. Fewer welds and a single-piece frame mean fewer vibrations. Inside the cabin, this translates to less rattling and a noticeably quieter ride. But the impact of the E0X platform goes beyond strength and driving feel. It also transforms manufacturing itself. Previously, producing and assembling dozens of separate parts required time, precision, and extensive testing. By replacing them with one large cast structure, the process becomes far simpler. Fewer parts mean fewer assembly steps, less welding, and fewer potential errors. This speeds up production and improves consistency in quality. In other words, the cars don't just become stronger, they become more efficiently built. The E0X platform isn't just a new technical upgrade. It represents a shift in mindset. It shows that true strength doesn't come from using thicker steel, but from smarter design and better materials. It points toward a future where vehicles are lighter, stronger, safer, and more comfortable all at once. Now let's move to another change that may sound like just a number, but could reshape the entire electric vehicle industry: 800-volt architecture. Today, most electric vehicles operate on 400-volt systems. That's the standard level at which their batteries and power electronics function. But shifting from 400 volts to 800 volts isn't simply about doubling the number. The impact is much greater than that. Here's a simple way to understand it. When voltage increases, the same amount of power can be delivered with less current. That means the system does the same work with less electrical strain. And in electric systems, high current generates more heat. So if you reduce the current, you reduce heat. That's where the real advantage of an 800-volt system comes in: less heat and greater efficiency. There's another key component involved: silicon carbide. Traditional electric vehicles use silicon-based power electronics. They work well, but they produce significant heat, and some energy is lost during the transfer process. When silicon carbide technology is combined with an 800-volt system, power delivery becomes smoother and more efficient. Thermal losses, the energy wasted as heat, can be reduced by around 50%. What does that mean in real terms? More of the battery's stored energy is used to actually move the car forward, instead of being lost as heat that needs to be managed and cooled. This improves the overall stability and reliability of the vehicle's power system. To put it into everyday perspective, imagine filling a large water tank. If you use a thin pipe, water flows slowly and unevenly. But if you use a thick pipe, the water flows quickly and continuously. An 800-volt system works like that thicker pipe, delivering energy faster, more smoothly, and with less resistance. Energy flows quickly, steadily, and with minimal loss. And this has its biggest impact on charging performance. Because less heat is produced, the system can safely handle higher power levels. That means the battery can charge much faster without the risk of overheating. With an 800-volt architecture, it becomes possible to add up to 150 kilometers of range in just 5 minutes of charging. Think about what that means in real life. Previously, before a long trip, you might have had to stop at a charging station for 30 minutes or more. Now, a short break is enough. By the time you grab a cup of tea or coffee, your car is ready to drive another 150 kilometers. But to truly understand the future of EVs, we need to talk about the area where the entire industry has been limited for the past 15 years: batteries. Lithium-ion batteries made electric vehicles possible. They powered the first wave of modern EVs and helped move the industry forward. However, they also brought challenges that could never be completely eliminated. From the outside, everything appears safe and controlled. But inside the battery cell, the chemistry is complex and not always perfectly stable. One of the biggest concerns is dendrites. These are tiny, metal-like structures that can slowly form inside the battery during repeated charging and discharging cycles. If they grow large enough, they can pierce internal layers and create a short circuit. When that happens, serious problems can begin. Another risk is thermal runaway. If the battery temperature rises beyond a critical point, the internal chemical reaction can accelerate rapidly and become extremely difficult to stop. Perhaps the most alarming scenario is a self-oxidizing fire. If a lithium-ion cell is punctured or severely damaged, the chemical reaction inside can release oxygen and fuel its own combustion. In such cases, even pouring water may not easily extinguish the fire. Instead of completely eliminating these risks, the industry focused on managing them. Manufacturers improved cooling systems, enhanced battery packaging, and added more sensors to monitor performance. These measures made batteries safer, but the core chemistry remained unchanged. In many ways, technology advanced, but only within certain limits. Over the past 15 years, there have been improvements, but no true breakthrough. The industry has largely remained confined within the same lithium-ion framework. You could call it a kind of battery prison. That's where the story begins to shift, with Kunpeng solid-state batteries. Under extreme conditions, traditional lithium-ion batteries can enter thermal runaway, but in these tests, the outcome was very different. There was no fire, no smoke, and no explosion. The reason lies in the solid electrolyte. Unlike liquid systems, it doesn't carry the same instability. Even when damaged, the chemical reaction remains controlled. For drivers, this means something very important: peace of mind. The quiet fear many people have about EV batteries could gradually disappear. If technology reaches a point where even severe damage doesn't trigger fire or smoke, concerns about battery safety may eventually become a thing of the past. So far, we've discussed the vehicle's structure and its battery. But a car isn't just metal and chemistry. It also needs a brain. And this is where another major gap appears. Even today, many traditional automakers still rely on a communication system called CAN bus, short for Controller Area Network. Developed in the 1980s, it was revolutionary at the time. It allowed different components of the car to communicate with each other efficiently. But the demands of modern vehicles are very different. Today's cars generate enormous amounts of data from cameras, radar sensors, driver assistance systems, infotainment platforms, and constant software updates. In this environment, the old CAN bus architecture can start to feel outdated. Its data transfer speeds are limited, the wiring can be heavy and complex, and response times may slow down under high loads. You might notice this in everyday use: a screen that lags, limited software updates, or difficulty adding new digital features. The CAN bus system was ideal for its era. But as vehicles evolve into software-driven machines, this framework struggles to keep up. In simple terms, the hardware of modern cars has advanced rapidly, but their communication systems often remain rooted in the past. This creates what you could call a brain gap, a new generation machine running on an old generation nervous system. To bridge that gap, a new architecture steps in: the Gigabit Ethernet-based EA 5.0 system. This isn't just a minor upgrade, it operates on an entirely different level. Compared to traditional systems, it can transfer data 100 to 1,000 times faster. Think of it like moving from dial-up internet straight to fiber broadband. With this kind of speed, the vehicle transforms from a purely mechanical device into a fully software-driven platform. This is where SOA, service-oriented architecture, plays a role. Instead of tying functions permanently to hardware, the system allows many features to be updated and managed through software. That means improvements don't always require replacing physical components. Over-the-air updates become smoother and more powerful. Just like smartphones gain new capabilities through software updates, cars can evolve and improve long after they leave the factory. At the core of this system are dual NVIDIA Orin X processors, delivering roughly 58 trillion operations per second. That number may sound purely technical, but its real impact is practical, especially when it comes to safety and responsiveness. Imagine a child suddenly running into the street. The car's cameras, radar, and sensors instantly capture the situation. The data is processed almost immediately, allowing the system to recognize the danger and respond. Sometimes, even before the driver reacts. Fast communication, powerful computing, and flexible software combine to turn the vehicle into more than just transportation. It becomes intelligent and responsive. Now, let's talk about something that directly changes how the car feels on the road: the flying fish chassis. The name may sound unusual, but the concept is straightforward. Traditional suspension systems are reactive. They respond after the car hits a pothole or bump. This system, however, is predictive. Using LiDAR-based road scanning, the vehicle reads the surface ahead in real time. It detects potholes, speed bumps, uneven surfaces, and changes in road angle before the wheels even reach them. This information is instantly sent to the control system, where CDC, continuous damping control, adjusts the suspension accordingly. The system constantly fine-tunes the damping force to reduce impact and maintain comfort. It also works together with a dual-chamber air suspension system. In a standard setup, there's usually only one air chamber, which limits how precisely the suspension can be adjusted. But with a dual-chamber design, the car can instantly switch between softer and stiffer settings, depending on driving conditions. The result is a vehicle that doesn't just react to the road, it prepares for it in advance. That's why many people describe the experience as a magic carpet ride. It feels less like driving on asphalt and more like gliding smoothly above it. The system also includes active rear-wheel steering. At lower speeds, the rear wheels turn in the opposite direction of the front wheels. This reduces the turning radius and makes the car easier to maneuver in tight spaces. At higher speeds, the rear wheels turn in the same direction as the front wheels, improving stability and control. In this setup, the suspension isn't just absorbing bumps anymore, it becomes an active partner in the driving experience. Now let's step back and look at the bigger picture. The change that isn't immediately visible from the outside, but could reshape the entire industry. For decades, the automotive world followed a fixed hierarchy. Certain brand names automatically suggested superior engineering and advanced technology. A badge on the hood felt like a guarantee, a promise that everything inside the car was cutting edge. But that dynamic is shifting. Technological leadership is no longer defined by legacy, history, or logo size. And this is where the combination of the E0X platform, Kunpeng solid-state batteries, and gigabit Ethernet-based systems becomes important. These are not just three independent upgrades. Together, they represent a generational leap, a stronger integrated vehicle architecture, a safer and far more efficient energy storage system, a faster, software-driven communication network. When these elements come together, the result isn't just a slightly improved car. It feels like an entirely new category of vehicle. The automotive industry is entering a phase where the foundation matters more than the badge. And as technology continues to evolve, the next major shift could come from places many people aren't yet watching. If you want to stay ahead of these deep insights into the future of mobility and electric vehicles, make sure to subscribe. Because in this industry, the next big transformation can happen sooner than anyone expects.